Okay, let's spend some time in comparison with widely used cluster autoscaler and Karpenter. At a high level, this is how it looks. You can see here pods get scaled maybe due to deployment or due to horizontal pod autoscaling. Then the pod goes to pending. What does cluster autoscaler does? It interacts with autoscaling group and then creates the EC2 instance. The same thing, what Karpenter does is it sees the pending pods and then it directly interacts with the EC2 fleet APIs and then creates the nodes. We're going to go much deeper into this. This is just a very high level. I wanted to show you the picture of how cluster autoscaler and Karpenter looks like. All right, let's go a little deep into the comparison. First, architecture and node provisioning. Cluster autoscaler operates, as we were discussing, by adjusting the number of nodes within the predefined node groups, such as AWS autoscaling groups. It monitors the pods that cannot be scheduled due to insufficient resources and scales the cluster by modifying the desired capacity of autoscaling group. Scaling actions are influenced by the configuration of these node groups, which can limit the flexibility over a period of time. Coming to Karpenter, it bypasses the need for node groups by directly interacting with cloud provider APIs, like AWS EC2 in this case, to provision the nodes. It observes unscheduled pods and rapidly launches right-sized compute resources tailored to specific workload requirements. So basically, it's gonna look for your workload, understand what is the requirement, and it's gonna dynamically create the right instance at right time, as Carpenter website says. This direct approach enables faster and more flexible scaling as it isn't constrained by the predefined group configurations like what we do with cluster autoscaler, where we have to be dependent on autoscaling groups. Next item, scaling speed and efficiency. In case of cluster autoscaler, scaling up can be slower due to reliance on autoscaling groups, which may introduce delays in node provisioning. Scaling down is very conservative, often terminating one node at a time after ensuring all the pods can be rescheduled elsewhere, leading to gradual resource optimization. But the same thing in case of Karpenter, it provisions nodes under a minute. The last time I saw it was 40 seconds uh, when I was testing. So it directly, interacts with EC2 APIs, allowing it for rapid response to changing workloads. It also supports advanced consolidation strategies, which we are going to go deep into upcoming sessions, such as empty node, multi-node, single node consolidation to optimize the resource usage and to reduce the cost overall on the cluster. All right, so the third item is flexibility and resource utilization. Cluster autoscaler scaling is based on predefined node group, which we just understood, and which may not be always aligned perfectly with our diverse workload requirements. That might potentially lead to over provisioning or underutilization of instances. Managing multiple node groups for different instance types or purchase options can increase complexity also over a period of time. I'm specifically talking about operational complexity. Coming to Karpenter, it offers greater flexibility by selecting from a wide range of instance types, availability zones, and then purchasing options like on demand or spot to match the workload demands. It also enhances resource utilization through intelligent bin packing and workload consolidation by reducing the resource uh, utilization and optimizing the cost. Coming to a few other points, as you can see, integration and compatibility. Cluster Autoscaler supports multiple cloud providers, including AWS, GCP, Azure, making it suitable for multi-cloud environment. It requires management of both the autoscaler and underlying node groups, which can add a little operational overhead. Carpenter initially designed for AWS, leveraging AWS specific services such as EC2 and EKS. There is already a work in progress, and I have seen for Azure and Google, I think the team is using Karpenter. I have seen recently one presentation from Azure team on their solution, Azure Kubernetes service called AKS. So the utilization and the adaptation of Karpenter is reaching to other clouds too. While there are plans, the multi-cloud support, its primary integration is with AWS, but not limited to AWS. So this Karpenter, as we discussed, it simplifies the operations by eliminating the need for node groups and directly provisioning the instances based on the workload requirements. That's a great thing about Karpenter. And coming to cost optimization, cluster autoscaler may lead to higher cost due to less efficient bin packing and the potential for over provisioning as it scales based on node group configurations rather than specific workload requirement. And Karpenter basically optimizes the cost by provisioning right-sized instances and effectively utilizing spot instances, selecting the most cost-effective options that meet the workload requirements. Also provides intelligent feedback strategies, launching on-demand instances when spot availability is low, basically ensuring continuous application uptime. All right, so these are a few things I wanted to discuss before we go further with Karpenter and comparison with Cluster Autoscaler, which is a widely used option across the industry.